Okay, so Whitney, Carol, Sue, what's the solution? Whitney, Carol, Sue, yeah, point D. What about Franklin? Whoops. Franklin 428. What did you say? I heard it. No solution. No solution. What about 428 and Carol Sue? E, good. So what does it mean for something, for a point to be a solution to two equations? Yeah, it's where they meet. It's where they intersect. It is where they intersect. Not intercept. Intersect. That gets a little funny, right? Intercept, not like a interception in football, but intercept, it's like your x-intercept or your y-intercept. An intersection, or where two lines intersect, is where they meet. The solution is the intersection. So what two roads or equations meet at point B? Whitney, yeah, Highway 90 and Whitney. What about at point D? Carol Seuss, like Dr. Seuss's daughter or something? No, I'm just making a joke. Not a very good one, but anyway, what about no solution? What two roads have no solution? Manhattan and what? Manhattan and Franklin, that works. What else? Berman. It does kind of look like Batman. Yeah, Franklin works. There's a bunch of different options, right? Woodland and Shirley, Woodland and 428, Woodland and Whitney. There's a whole bunch of intersections. And what does it mean when something has no solution? They don't intersect. Exactly. They do not intersect. Okay. Is it possible for two equations to have more than one solution? How? Can you give me an example of one? Well, Carol Sue is just one road, right? And you're right, it has 2 points on it. That's fine. But so does anywhere has like 2 points on it. But can you think of two roads that intersect more than once? Two roads that intersect more than once. Huh? And what? Highway 90 and what? Yeah. Look, it intersects with Franklin right here. And it intersects with Franklin right here. And Whitney as well. It intersects with Whitney once and twice. So yes, it is possible, but what has to be true? What's special about like Highway 90? It curves, exactly. So the only way to have two roads intersect more than once is one road needs to be curved. So yes, but one road, at least one road, both of them could be two. One road must be curved. Okay. So last year I made my students draw a map of Cortez and we talked about that. But we'll just look at the actual map. So can you think of two roads in Cortez that intersect one time? Main Street with what? You gotta give me two. What road does Main Street intersect with? There's lots of options. Chestnut or Market. Yeah, good. What about two roads that don't intersect? Arbacam and Main Street. Empire and Main Street. Good. What did you say, Anthony? Empire, Main Street, or Empire and Montezuma, right? Those. Can you? What about a road that intersects with another road twice or more than once? Two roads that intersect more than once. Huh? What did you say? It's okay. Mildred. So Mildred, I don't think Mildred's going to intersect with any road like more than once. Could be wrong. I don't think so. I think those are all different roads. Can you think of a road that intersects with another road more than once? I can only think of one. Well, kind of two, but they're in the same place.
Is it like?
Yeah, yeah. Look, this is Park. And I just know this because I walked my dog and I noticed Birch and then I noticed Birch again. And I thought, oh, well, this road has to curve all the way around. If it's intersecting with Park twice, then it's got to curve at some point. And same with this one, Aspen, it curves. And so that there's two intersections there. Okay. No, now we got to move on to the equation. So this is the exact same thing, except we're not looking at roads anymore. We're looking at equations and looking at the coordinate plane. So look, I've got y equals x, and I have y equals negative 0.25x. I can find those lines on my graph because I know what my slope and my y-intercept is, but also because they were really nice and they labeled them for me. So where do those two lines intersect? Where do they meet? 0, 0, right here. Right here. 0, 0. So that's the solution. Can you guys fill out the rest of the table, please? Fill out the rest of the table, please. All right. I've got y equals x plus 5. That is up here, this line. And y equals 4, which is right here. Where did those two lines intersect? Huh? Where do they intersect? Negative 1, 4. Not negative 1 over 4. That's a fraction. No. Negative 1, 4. Choose a comma in between, parentheses around it. What about y equals 4? That's this one, y equals 4. And y equals x. And y equals x. 4, 4, good. What about y equals x plus 5? And y equals x, good. No solution. What two lines meet at negative 4, 1?
X equals x, no, y equals x plus 5 and y equals negative 0.5.
Yeah, y equals negative 0.25x. Good. Right, this green one and this one. What 2 points meet at negative 5, negative 5? Or what two lines meet there? Y equals negative 5. What about two lines that don't have a solution? I know these two don't. Y equals x plus 5 and y equals x Is there any others that have no solution?
Y equals negative 0.25x and y equals negative 5.
Do we agree with Anthony?
No.
Why not?
Or if I do-
Huh? Do we agree with Anthony? Does this green line and the pink line down here, do they intersect?
Yeah.
might be-
literally
Yeah, they
said
will.
You change your mind?
Yeah.
Why'd you change your mind?
Because if you keep going, the green line keeps going, and it'll be like
15.
That's it. So just because they might not intersect on your graph, remember these lines go infinitely in both directions. So those two lines will intersect eventually, even though they don't intersect on my graph. Can you tell me two lines though that will never intersect?
Y equals 4 and y equals negative 5.
Good. Do you know what those lines are called? Good. Parallel lines. Parallel lines never ever intersect. All right. Is it possible for two linear equations to have more than one solution? Why? Yeah, because the only way we could get more than one solution is if we have a curved one. But linear equations are always straight lines. So we have three options with linear equations. We might cross one time, and there might be one solution. They could cross never. We have parallel lines, and those have zero solutions. Or we could have the exact same line. The exact same line. And how many solutions do you think that would have? Huh? I heard it. Yeah, infinite. Infinitely many solutions. It's a lot. It's like the most you can have. Okay, so no, it's not possible to have more than one solution. I guess it is possible, but the only way it's possible is if you have infinitely many solutions, if you have the same exact line. All right, let's flip over to the other side and we're going to look at the trees. Polly and her trees. She's got a magnolia tree, which she planted in her front yard. And how tall was it when she planted her tree? Is that what it says? 4 feet tall. It was. And at the end of each year, she measured the height of the tree. We've got a table. We want to use this table to graph a line. Okay. So what variable is my years? What axis is it on? X or Y? X. And what about the tree height? Y. So year 0, the tree was 4 feet tall. There's that point right there. After 1 year, how tall is the tree?
6 feet.
After 2 years, how tall is it?
8 feet.
After 3 years?
10 feet.
And after 4 years?
12.
12 feet. There we go. We've got a line. Okay. Can we write the equation for that line?
Y equals up 1 over 2 or up 1 over 1?
Up 2 over 1. And what's the y-intercept? 4. So what's my equation? Y equals 2x plus 4. 2 over 1x plus 4. Good. What does the 4 represent? It's the y-intercept, but what does it represent about the magnolia tree? The starting point of the tree. What does the 2 represent? Yeah, it's growing 2 feet per year. Good. Okay, now she also is planting a pear tree in addition to her magnolia tree, but she's planting her pear tree from seed. So how tall is the pear tree when she starts? 0 feet tall. And can you look at this equation and figure out how many feet it grows per year? 4 feet. Yeah. I don't know. It doesn't seem possible to me. But, you know, We keep it simple. Maybe. Maybe it's a magical pear tree. So after 1 year, how tall is the pear tree? 4 feet tall. After 2 years, how tall is it? 3 years? 4 years? Good. I've got this line. So again, what does this 4 represent? It's the slope, but it's the rate it's growing per year. And what is the y-intercept? Why is there no y-intercept? Why doesn't it say plus b? Because it starts at 0. Starts at 0 height, right? So plus 0. Okay. All right, now in part C, we kind of already talked about this. What's the rate at which the magnolia tree is growing? How many feet per year? Huh? 2. What about the pear tree? So who is growing faster?
The pear tree.
Yeah. Pear tree is growing faster. So what you're going to need to do is you're going to need to draw both graphs down here on the same coordinate plane. So you've got your pear tree starts at 0 and it's going up 4 every year. Going up 4 every year. I've got that line of my pear tree. And then I have my magnolia tree, and that one started at 4 and it's going up by 2 every year. So you should have both lines graphed. Both lines graphed on this same exact thing. I got messed up. Let me do it again. Now, I want you to circle the point at which the two graphs intersect, and then I want you to tell me what does this point represent in terms of the two trees and the amount of time they've been growing. Circle the point where they intersect, and then tell me what that point means. What does it represent? So where do these two lines intersect? 8, 2, 8, 2, 2, 8. So what does that point represent?
8 feet in 2 years.
Yes, both trees. Sorry. Both trees. Hey, go put your Sonic cup in the trash. Both trees are 8 feet tall after 2 years. I was looking for both numbers to be mentioned. Both numbers. Not just one, not the other. And not just, that's where the trees are the same height. Tell me when, tell me how tall they are. Can you put your phone away, please? All right. Flip back over to the other side, and we're going to do these 3 problems together, and then you're going to do the other 4 on your own. All right, so this should feel really easy to do after having graphed inequalities last week.
That's what I was thinking.
It's so much simpler. Remember, for inequalities, we had 4 steps. We had to plot the y-intercept, and then we used the slope, and then we had to decide is it dotted or solid, and then we had to decide if we're shading above or shading below. Now, it's just those first 2 steps. Plot the y-intercept, plot the slope. So look at this first equation. Y equals negative 3x plus 4. Anthony, what's the y-intercept? I don't know if you were paying attention and not laughing about your Sonic cup, you would know. Excuse me? What's the y-intercept?
4.
So where do I go to 4 on my y-axis or my x-axis? Y. And what's my slope?
Up 3 down 3 over 1.
Good. It's negative 3, so we go down 3 over 1. Down 3 over 1. And I like to keep counting down and over, because that ensures that you will have an accurate answer. Because if you just do 2 lines and then you're like, blah, I don't know. then you're going to be all over the place. You got to count down, really stay accurate. That wasn't very accurate, was it? There we go. Okay, what about the second line? What's the y-intercept? Very good. There's no b. That's like adding 0. B is 0, so I start at 0. Good, my slope is 1, so I'm going up 1 over 1. And look at that, up 1 over 1. I have an intersection. But this is not enough. You also need to tell me where the intersection is. What's the intersection? 1, 1.
1 over 1.
What?
Over 1 up 1.
Like that?
No. 1
1,
1.
1. Thank you. How about number 2? I've got 2 lines here. What's the first equation? What's the y-intercept? 2. So I start at 2. What is my slope? Good. It's -1. So I'm going to go down 1 over 1. 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 And I can go back this way, right? Because my lines go infinitely in both directions. What about my second line there? What's the y-intercept? -1. So that's right here. And what's the slope of that line? Down 1 over 1. Down 1 over 1. Where are these 2 lines going to intersect? Never. They're called parallel lines. And what do you notice about those parallel lines and their slope? They're the same. Look up above at the other problems we looked at earlier, these ones. Look at my parallel lines, these 2. What are the slope of those 2 lines, my horizontal lines? It's the slope of a horizontal line. 0. What's the slope of this line? Yeah. And what's the slope of this line? So parallel lines have the same slope. So when we have the same slope, they're parallel lines, they never intersect. There's going to be no solution. Okay, one more to do. Y equals 1/2 x plus 1. What's the y-intercept? And what's the slope? Up 1 over 2. So I start at 1, up 1 over 2, up 1 over 2. Oops. And what about that second line? My y-intercept is -1? -5. So I start at -5 down here. And what's my slope? Up 2 over 1. 2 over 1, up 2 over 1, up 2 over 1. There it is, that intersection. Where is that intersection? 3, 4? 3, 4 is up here. 4, 3. Good. X is first and then Y. All right, so you have numbers 1 through 4 to do on the other side of that paper. 1 through 4. And you should graph both lines and tell me the solution. Graph both lines and tell me the solution. None of those have no solution. So don't tell me no solution because that's not right. Okay? Do numbers 1 through 4. I'm going to come around and check in 5 minutes. 5 minutes. That'll be my